So, good afternoon, everyone. And first of all, thanks for joining me in this talk. And I'm going to talk about unleashing the power of vector search and semantic caching in Java. That's me. I'm Luigi Fugaro. I'm a solution architect in Redis. I've been in this IT since 1998, more or less. So I started with Clipper, Basic, Pascal, everything. Then, without going too much deep, in my last experience, I had a great experience in Red Hat, 7 years, then Datadog, and then now it's about 2 years that I'm joining, that I've joined actually Redis. So, the talk is about unleashing the power of vector search and semantic caching in Java. That means we are going to talk about vector, caching, and Java. Those are the main three focus of this talk. So first of all, a bit of recap regarding vector embeddings, what they are. And so vector embeddings are actually used to represent unstructured data. Unstructured data are all the data that you cannot find a specific pattern or organization within the data itself. Like, for example, in tables, you have structure, so there's a structured data. In CSV file, you can find a pattern. In logs, you can find a pattern. So every time you can understand and perceive an organization of the data, that's structured data. Maybe sometimes it's also called semi-structured data. All the other data are classified as unstructured data, like images, video, audio, anything that cannot be, that doesn't have a structure immediately. And those vector embeddings are actually a list of numbers, to be precise, floating numbers. That means are float of 8 bits, 16 bits, 32 bits, 64 bits. It depends on the precision that you want to have within your vector embeddings. The more the precision, the more the accuracy of representing the data, and of course, the more the footprint in memory that you will have. And each vector that you have with your vector embedding has a fixed size, so it doesn't happen to that you actually have an embedding of, I don't know, like 50 elements, then the next one is 100, and then 70. It's always the same size. And they actually represent, is a compact representation of the data. How to create a vector embeddings? First of all, you need to have an input. So that input gets transformed into a numerical representation, as we saw. And this input gets is actually given to a model with extract features that characterize that specific data. And that model applies all these machine learning and deep learning algorithms. And then with the neural network, it will extract all those characteristics. And each characteristic will be placed into the vector embedding, so at specific items of the vectors. The result of this of the model is the embedding itself, as we will see. However, mostly probably since the 90s, we always use a vector embeddings, or at least we saw it a lot of time without even knowing. And that was the RGB, red, green, and blue. It's three sides vector, each representing a characteristic for the color red, another one for the color green, and another one for the color blue. And as you may know, in HTML we need to manage the colors with RGB, and each characteristic may be a range of number in between 0 and 255. That means I can actually have a color represented by 3 bytes, and the color that I can have in RGB are more than 16 millions. So we go back to the how I can represent a color in a compact, dense representation using vector embeddings. Only 3 bytes, and I have my color. And then, of course, this will be placed in a multidimensional space in the concept of vector embeddings, somewhere in this scope. However, now that I have my vector embeddings, I need something to store those vector embeddings. And I need a database, a vector database that can actually manage and persist those data, can index those vectors, so I can apply query and search for vector embeddings. And this is where it comes Redis as a vector database. The flow to interact with Redis as a vector database is the same. I got inputs. I apply that input to a model, which transforms the input to an embedding, to vector embeddings, and then I store that vector embeddings inside the database. Redis also gives you a functionality which is called vector similarity search, and this actually, the vector similarity search, it's a method to calculate the distance between vectors. And there are many algorithms that you can use, like the Euclidean, Manhattan, cosine similarity, and so on. And they all calculate a score of similarity. So the matrix, the distance between vectors. Let's see an example. I will have a text, apply a model to it, and then the vector embeddings will be stored into Redis. This is the flow, how it will happen. So I'm going to transform the first sentence, that is a very happy person, then that is a happy dog, and then is a sunny day, all with the same flow. It will be memorized inside Redis. Then I will have if you kind of represent those vectors in a bidimensional space, you may have this kind of a representation, this positioning of the sentences. And you can start also seeing a kind of, let me say, context, all the vectors that where we have something that is happy are close to each other, rather than the other that is as another direction. Now, if I want to actually query those data, I still need an input, and the input will be again a sentence, which will be applied to the embedding model, which gives me the vector embeddings, and then I call the vector similarity search in Redis. Okay? In this case, the sentence is, that is a happy person, and again, in multi-dimensional space, here you can see that the one that is more close is that is a very happy person instead of just happy. And if you represent this in a bidimensional space, you can see that that is a happy person is closer to the other sentence that is a very happy person, because we applied the cosine similarity, which calculates the angle between the two vectors, the one in inputs and the other ones. So the smaller the angle, greater the similarity. Redis itself also provides other functionalities like, of course, indexing. So you can actually choose between two main algorithms for indexing your data, your vectors, which is, one is called flat, and the other one is called HNSW. The first one goes for, as I wrote, a brute force, means that you're going to scan each vector inside Redis, and then it goes for more accuracy. And of course, you will need to spend more time on the query. And the other one goes for approximation. So that means you will have more or less benchmark saying 97, 98, 99% of good results. Of course, the benefits would be the performance. It will be much faster. And then Redis supports those three algorithms to calculate the distance: Euclidean, inner product, cosine similarity. And also you can do hybrid query. What it means, in Redis there isn't a type, a structure to represent just the vector embeddings. You need to use other structure like hash, which are maps, and JSON. So it's like the hash, but with hierarchy, and you can have nested documents inside a JSON. And so the other attributes of your structure on the maps or in the JSON might be metadata to represent your data. So you can filter first on your metadata and then apply the vector similarity. This translates to be, of course, to work on a subset instead of the entire dataset that you have inside your vector database. And the types that we support for filtering, it's geo, spatial structures, numeric, text, tags, filters, and many others. Another thing that Redis support is the real-time updates. That means on the index, whenever you update your data, the index get updated as well. So you will not have any, because when you do the query, you actually do it on the index. So you will always have the index updated, so with the state and consistency of the data. And then vector range queries. That means when you do the query, I don't want to have vectors returning from a query that are, I don't know, like 20% of score. I want them to be at least at 80, 90% of similarity. I don't care about the rest. So this is how you can apply with vector range queries. So how to implement a kind of generative AI application with all this? First of all, you need to, let me say, calm down, relax a bit. And there is a framework which is called Redis OM. Redis OM stands for Redis Object Mapping. And this allows you to map your domain and model your domain, targeting Redis as a vector database. So abstracts you of all the complexity to create the index, specify if it's text, if it's numeric, if it's a vector embeddings, etc. All you need to do is actually apply the annotations available within the framework. And then, of course, aside from the vector embeddings, you can have also implement CRUD application directly with Redis OM. Okay, let's see a short demo. And let's see if everything works. Hola, all right. So first of all, a bit of, here is Spring Boot application. So what I've done is like configure the connection to Redis, and then with Redis OM, I enable the DJL. DJL stands for Deep Java Library. It's a library that encapsulates and abstracts, wraps the PyTorch engine and brings the PyTorch to Java. And here you can also specify which model you want to apply, and you can apply to your domain. If you're dealing with images, if you're dealing with faces, if you need to do face detection, if you need to do sentence transformers, and so on. You can manage everything from the properties. And from a model perspective, how you model your data, it's, I don't know if it's readable. Here is my, I would say, my Pojo. So the document says that it's a JSON structure. Then I'm telling that a index the member name, index the height and the width, and automatically the index will get his type, and so it will be a numeric index. And then here is the the image path, so the source where the image are located, can be local from the file system, could be a URL, whatever. And what it does automatically is, because I use the vectorize annotation, it will vectorize that image using the embedding type as a face in this specific implementation. And then the vector embeddings resulting from the transformation will be placed in that other members of my class, which is the image embedding, which is right above, which is an array of float. How do I index this array of float? So how I index my vector embeddings? There is another annotation. It's still the indexed annotation, but then you need to specify that it's a vector, which kind of algorithm I can use for my index, the precision of my vector, of my floating numbers, in this case 32 bits, the dimension. The dimension is actually, it's given and provided by the model. It's because the model actually has, gives you the vector embeddings. It tells you the size of the vectors. So you need to be careful when you specify the dimension that needs to match the one that is output from the model. And then how you want to calculate the similarity of the vector. So Euclidean, inner product, or cosine similarity. And that's it. Then the initial capacity stands just for filling up the vector with the first 10 elements. Nothing really complex. It's just few annotations and your model is done. Then what happens when you start feeding and then saving those objects inside Redis? All this happen under the hood. So the transformation, the vector embedding and contacting the models, and the DJL library downloads the model that you specified in the configuration files. So everything will be done for you. Now let's see. Yeah, let's run the application. This will connect to the compute engine in the cloud on GCP, where there is Redis. And here is, that's Redis Insight. It's just a tool to see what's inside Redis, that you can have it. I don't know if it's visible, but here it says that there are 116,000 keys. And that says actually that there are 116,000 images on this Redis instance. Here you can see the structure, which is a JSON of this element. Here are the embedding, so our floating numbers. Each element will represent the characteristics of that image. If you want to know what each element, which characteristics is talking about, you need to go to the model, study the model, and see how it's done. However, it should be 500 or something. Yes, 512. And then here the image path. This is the one that we used to load the image. And then with the vectorize annotation, Redis OM grabbed the image, gave it to the model, which then translated into the embeddings that we just saw above. So let's go back to the application. Now it's running. When it starts, Redis OM will try to find all the structures such as hash and document to eventually index them. This was already done. And see here it says, I don't know if it's visible, but no, I cannot. Okay, like this. So it says it found 2 documents and it's ready. So what to do? There you go. Let me just switch a bit. Now, I will use the Redis OM face detection tool to actually detect my face in this case, and then show the result. The result should be me on the left, my face, and then as soon as I click my face, it will connect to Redis and then apply the vector similarity search with my face against all the other thousands of images. And yeah, that's the result. Any volunteer to eventually try come up on stage and try its face detection? Don't be shy. I did it first. So of course it will detect the characteristics that might be, I don't know, eyebrow, nose, ears, I don't know. Doesn't have to be like, oh, you're brothers, so you're similar. No, it doesn't work like that. Okay. Let's see. No regrets. Well, at least we have someone with the glasses, so again, but yeah. So that's how you can actually build something. Of course, you need to have. There was probably those. It's a set that I use, which is available on Hugging Phases. I should have probably used a data set where there were just faces, not pictures where you actually see the pose and the body of the person. So it would have been more precise on the output. And now, how do you calculate? How do you actually do the query? There is. Let me go on my service, best of match service. So again, you grab the input. In this case was my face, the floating array of my face representing my face, and then there is an object called entity stream available on Redis OM, which is ready to use, where it says, okay, let's do a query on this kind of object. In this case, the image data, which is our POJO annotated for the vector similarity. And then on the stream, it filters for the image embedding that I provided, which is in that case, my face. I do a KNN, so it will go through the approximation, and then I will pass my embedding as a byte array. Then I sort everything by score, so because I want to have the upper score as first elements, and then I limit my my output to specific numbers. I don't remember what was it, but probably 4 or 5. And then as output, I want to have specific fields. In this case, I want a pair of all the entire image data and the score. So it will be easier for me to actually work with those data, especially with the MVC approach. So I will have those pair, the image data and the score, put in the list, and have them back on the client side. But as you can see, the vector similarity search itself is just 6-7 line of codes. So there isn't much that you have to implement. You just need to follow the API, and of course there is the good documentation for the API, but it's pretty clear. It tries to map also what the JavaStreams API allows, more or less. Any question on the code? All right. Okay, let's see on the POM. all the need, what you need actually, you need to import as a dependency is the Redis OM Spring dependency and the deep Java library as a dependency. So the rest is just a Spring Boot application. This in this case. And let's go back. So Redis as a database and Redis OM as a framework can really help on building a Gen AI application. So targeting things like vector database that are also useful for many use cases, like, I don't know, question and answering, RAG, semantic caching, etc. And there is an ecosystem for AI in Redis. There is a very deep integration with two main frameworks, which are LlamaIndex and LangChain. Our part of our engineering team is actually working on those frameworks with the respective engineering teams. Here is a recap of the features that you can have in Redis. So the vector embeddings should be placed in hash and JSON. You can index with those two algorithms. The how to calculate the distance between vectors is given by those three algorithms. So inner Euclidean, cosine, and inner product. And of course, the rest would be also available for building a CRUD application with, so we're creating a resource, reading, updating, and deleting a resources. Now, I don't know if your mobile works, if you connect to the internet, but I don't think so. There was the intention to also have a special quiz to eventually win a prize, but with no internet, we cannot do it. But if you let me, we can try it anyway. Let me just without skip. Yes. So the first question would have been, what are vector embeddings? But it doesn't show. Hold on. Oh, I'm offline. Never mind. Hold on a second. Sorry. See if this one works like this. No, it's offline. Never mind. So there was the presentation. So thank you very much for listening, for your attention. And unfortunately, couldn't have the